Hello, this is video for Mathematics for Game Programmers courses 3D Geometry module, and in this video I will answer these questions, and I will go straight away for this first question, which is how to calculate whether two spheres collide. And for demonstration I will use Paint. So I have this formula here which is used to calculate the collision between two spheres. And what this means are the R1 is first sphere's radius, R2 is second sphere's radius, C1 is first sphere's center point coordinate, and C2 is second sphere's center point coordinate. And the calculation will happen by adding these two radiuses, and those must be greater than the negation of these two coordinates, the length of these two coordinates, which is calculated by using the Pythagoras theorem. So let's try to calculate that using the values. So let's say R1 is 1, R2 is 2, C1 have coordinate 0, 1, 2, and C2 have coordinate 3, 2, 1. So using that formula, let's put the 1 plus 2 there. The radiuses, those are those greater than the negation of these coordinates, and I will go the phase by phase with this Pythagoras theorem. I will not add the whole formula there at once because that gets messy pretty easily. So first I just calculate the negations of these. So 0 minus 3, 1 minus 2, and 2 minus 1. So we get the radius is 3, it's greater than length of this. So minus 3, and now I add the next phase of the Pythagoras theorem, which is powering by 2. I add those, powered by 2, and minus 1, powered by 2, and 1 powered by 2. Again we have this 3 is greater than minus 3 powered by 2 is 9. And now I add the plus operator, which is used to sum all these values. And minus 1 powered by 2 is 1, and 1 powered by 2 is 1. And well, again 3 and is greater than the length of 11, and now we can get the next phase of Pythagoras theorem, which is square rooting this sum, and finally we get the 3 greater than square root of 11, which is 11 square root is 3.3. And like we see, 3 is not greater than 3.3, so there is no collision. So that is it's a pretty straightforward and easy calculation. Just remember to use all the bases in Pythagoras theorem. And I will continue to next question. Okay, next question is how to calculate whether a plane collides a sphere. And so I have this formula here, which is used for collision detection for sphere and plane. And here's the S mean sphere's center point coordinate, P means normalized plane equation, and R means sphere's radius. And the calculation happens that we get the length of the dot product of the sphere center point coordinate and normalized plane equation. And we compare that to sphere's radius, and if the length is less than the sphere's radius, then the collision happens. So I have these values for each of these here, and I make the calculation using those values. So let's make the dot product. Dot product is just multiplying each of the corresponding coordinates and adding them together. So we have this 0 times 0 plus 1 times 0 plus 2 times 5 plus 5. And it goes by itself because plane equation only have the fourth dimension. And that calculation is compared to sphere's radius, which is 3. And we get the calculation 0 plus 1 plus, I think there's some kind of mistake, I think 0 times 0, 1 times 1, 2 times 0, 2 times 0 plus 5, alright. So 0, 1, 0 plus 5, and is that less than 3? So adding those together we get 6, and comparing that to 3, it's not less than 3, so again no collision happens. And yeah, this calculation, it's that easy. Just make the dot product and you need to do nothing to this comparing part. It's just a sphere radius. And remember to normalize the plane equation, or use normalized plane equation for this formula. And yes, I will go to next question.